Okay, let's get started. We're going to look at functions of several variables, which is what we're going to be studying for the most part in 17C. If you took 17B, especially if you had me for class, in class, we looked at some of these already. So this is kind of a review. We did a little bit of 3D graphing at the end of 17B. I still think it's important to review these ideas as we look at some more complicated graphs that we're going to be looking at soon. So one of the more important graphs in three-dimensional graphing is just the graph of a plane, a flat surface. And a plane can be identified just like with a two-dimensional graphing. If you have x and y both to the first power, that's a linear function, so that would look like a line. If we throw in a z term also to the first power and have it equal to some number, that's considered linear in three-dimensional graphing, but it's actually the equation of a plane. And the easiest way to graph a plane is to find its intercepts. To find the z-intercept, you would set both x and y equal to 0. And if you do that, z is going to equal 6. To find your y-intercept, you can set x and z both equal to 0. That would give you just 3y equals 6. So you would get a y-intercept of 2. And your x-intercept, you'd set y and z equal to 0, and you get 3, 0, 0. So that's a plane. You should know how to graph those. Another idea that we looked at in 17B is the idea of a cylinder. Not necessarily a circular cylinder, but I'm going to start with that. So in three-dimensional graphing, x squared plus y squared equals 9 has the form of a circle in two-dimensional graphing. So the way we plot that in 3 dimensions is that's a circle with a radius of 3 on the xy plane, on the xy axes. And notice z is missing in this equation. And so what we do is we take that circle, and if you can imagine extending that circle in the z direction, it goes up and down. I'm just going to extend it upwards. And so what you actually get is a cylinder, a circular cylinder. And let me show you another example of a cylinder, but not a circular cylinder. We still call this a cylinder. Okay. Here's my next example. Now, a lot of times when we have it solved for z, remember in previous calculus courses, we would call something f of x, and that was just a fancy name for y. F of x comma y is a fancy name for z. So z equals x squared plus 1. That has the form of a parabola shifted up 1 on the z-x axis. So that would be this parabola right here. Notice it's on the x and z axis, so it's a sideways parabola, looks sideways. And similar to the cylinder that we did before, y is missing this time. So we're going to take this parabola and we're going to extend it in the y direction indefinitely. And so it's going to look like, kind of looks like a sheet of paper folded. But that would also be identified as a cylinder. Probably more accurately, we could say this is a parabolic cylinder rather than a circular cylinder. But any two-dimensional graph that's extended perpendicular to the plane it's drawn in, by definition, is a cylinder. So this would still be identified as a cylinder. Okay. Another important graph to look at in 3 dimensions would be, I've already got it sketched here, so you can see that this is a sphere. And a sphere would have x, y, and z all squared and added together equal to some number. You should recognize without the z term, that looks like a circle. So this would be the 3-dimensional equivalent, which is a sphere. And what I want to talk about here, and we're going to use this idea in my next video here, is the idea of a trace. So a trace is a two-dimensional graph at a specific x, y, or z value. So for example, if I make a little chart here and look at some planes and what the trace would look like, the trace in the xy plane when z equals 0, you literally can let z be 0 here. And notice that's a two-dimensional graph. That's a circle with a radius of 5 on the xy plane. So that trace would be right here. That's like, you think of the sphere as the Earth, that's kind of like the equator going around the center. So it's a two-dimensional portion of that sphere. The trace in the YZ plane, which is when x is 0, let x be 0 there, gives you y squared plus z squared equals 25. That would be the circle right here. When x is 0, it's like squashing this sphere into the paper. It's literally this outside circle right there. When y is 0, in the xz plane, I get x squared plus z squared equals 25. That's this, I don't know if you can see the color, but it's in purple here. And that's kind of like if you're familiar with longitude lines, that's like the longitude line that goes from the North to the South Pole. Now you can do traces in any x, y, and z values. So I did a couple more. If I let z equal plus or minus 3, again, just plugging that into this equation, that's going to give me 9. If I subtract the 9 over, I get x squared plus y squared equals 16. And what that looks like is on your graph at z equals 3 and z equals negative 3, at those elevations, you're going to have a horizontal circle here. That's what this circle is. And notice it's kind of like the equator one, but of course it's a little bit smaller, right? It has a smaller radius. Same thing at negative 3. I also did a couple traces for y equals plus or minus 4, and that would give you 16 if you plug it in here, subtract that over, and you get a circle with a radius of 3 at y equals 4 and y equals negative 4. So those would be these vertical circles going around the y-axis at y equals 4 and y equals negative 4. So the idea of traces, if you didn't know that this graph was a sphere when you saw it, most people are comfortable graphing these. These are circles, right? And notice when you put these together, I like to think of it as it kind of looks like the skeleton of the overall three-dimensional surface. So if you did enough of these traces and you started seeing circles everywhere, every cross section is a circle, you would probably put together at some point that the overall shape of this graph is a sphere. So traces are going to be very useful to sketching graphs that maybe we don't recognize, and we're going to do a couple on the next video.